attention to what I want to do now. I want to go back to X and Y. Okay. How do we find the expectation of, the other time I walk you through finding expectation that has to do with a random variable X or with a random variable Y. But right now, okay, I actually have a random variable. It's a g of x, y. A function can be a combination of two different random variables. And maybe I realize that that function itself is discrete. If it is discrete, if I want to find the average of the function, okay, then this is what I'm going to do. If I want to find the average of the function, I'm going to have two summation. This is the function here is a random variable. Then the f of x, y is the joint mass probability function for that. If it is continuous, okay, if it is continuous, I'm actually going to do this. If I want to figure out if it is, you can see the integral replace the two summation sign. Don't forget my random variable here is g of x, y. Okay, now I'm going to walk you through an example right now. Okay, this example is going to come from whenever you see something presented in a table like that, that is for discrete. We can present continuous that way. Now, you have this guy now. Do you know that the f of x, y, which is the probability of the joint occurring, is what they gave in the table for different combination? Okay. Now, the question now is, you want to find, you know what I mean? I want to find expectation of a product. Okay. I want to find expectation of a product. Why do I need to find expectation of a product? You know why? Because if we want to find covariance, we need the expectation of a product inside covariance. What do we use covariance to do? The covariance can tell us the direction of two variables. When you study relationship between two variables, covariance will be able to tell us what is the direction. Is direction positive or negative? And the moment I know covariance, I can determine correlation. There's a difference between covariance and correlation. Covariance will only tell us the direction, but correlation will tell us both direction and the strength. Does that make sense? So both direction and the strength. Covariance cannot tell us the strength, whether it is weak or strong. Okay, now if I want to do that here, look at what I'm doing. X, Y, I'm going to 0, 0, multiply by its corresponding probability. 0 times 1, multiply. I'll do that all the way, and that will give me 3 over 4 when I'm done at the end of the day. Is there any question on how to go about that? Finding the expectation of a product. Any question on that? Okay, you're going to do a lot of stuff. You can see, start from 0, 0, you're going to end up in 2, 2. Okay, not 2, 0 is going to go. But the reason why I did not consider because of this 0, because what is the sense of doing that? Does that make sense? And that's why you see that I ended in 2, 0. Does that make sense? I ended in 2, 0 because this is where I have a number. If I continue this 0, 0, so I was like wasting time. Does that make sense now? Okay. Now, take a look at this. This relationship exists. If x is a random variable, y is a random variable. Whatever I'm doing to them, also going to be a random variable. X plus y will be random variable. X minus y will be random variable. X multiplied by y is a random variable. And it's going to be that. Okay? And some of you may be wondering, when do we need this? Okay? Imagine you have a company, you are producing two different materials. What you produce here varies, what you produce here varies. Now, if you now want to know your total production also varies. When you add x to y, and you want to find the average, that also varies. Or you want to find the difference, the difference also varies. Okay, I'm going to move right now. Now, I want to present to you another way to figure out if x and y are independent. There's so many ways to show. This is another way to show. Do you know if x and y are independent, expectation of a product can be expressed as the product of the unconditional means. Take a look at that. And we have a proof for that. Okay, if this guy, okay, is the expectation of a product, if X and Y are independent, I will be able to split into this and this, which the first one is going to be expectation of X, and the second will be expectation of Y. Okay, that is when X and Y are independent, expectation of a product is going to be that. Okay, now I need you to take a look at this example now. Take where we are now is super easy. If you take a look at this example now, it is known that the ratio of a gallium to arsenide does not affect the functioning of gallium arsenide wafer, which are the main components of microchips. Now let X denote the ratio of gallium to arsenide and Y denote the functional wafer retrieved during a 1 hour period. And they've given you this information. Please pay attention. You can see what they just told you now. They said X and Y are independent. And the question is, this is a function, right? This is f of xy. Now, if X and Y are independent, you know what happens? You have to know that if I want to get, let's say for instance, somebody asked me to get expectation of the product, and if they told me X and Y are independent, I can decide to force obtain expected value of X and get expected value of Y, then multiply them. But let me tell you this, before you can obtain expected value of S, you need to first come back to this place and get f of S. Does that make sense? And get the marginal function f of S. Okay? Now, if you take a look at, now this is what happened when I decided to go all the way, like solving it directly, expectation of a product, using the formula here, using give me 1 second, using this formula, expectation of a product, expected value of xy is going to be xy, f of xy. When I use that directly on the data, that actually give me 5/6. You can also try that. When I did that separately, doing that separately is 4 of us getting f of x. After getting f of x, I got e of x. Then also go back to the join and get f of y to be able to get e of y. I got this guy. Do you know, when I multiply this guy by this guy, the result is this guy when they are independent. But if they are not independent, it's not going to be equal. That's exactly what I'm doing here. Does that make sense? Okay. Now, I'm going to move right now. At times, a random variable can be ax plus bs, where a and b are constants. And I want to find the variance of this guy now. You remember what we always do? It's going to be a squared variance of x plus b squared variance of x, which is going to be this guy here. Do you see that? Okay? The same thing is applicable to when you're doing minus. It's still going to be that. But this only applies to situation where x and y are independent. If x and y are independent, the covariance is going to be equal to 0. But what if in a situation? Now let's now generalize. Take a look at this. My random variable now. You see that? That's a random variable. ax1. Or where a1, a2 up to an are constants. Okay? We take a look at what I have. Okay? Then I'm going to have this. Okay? Now, if I have that guy now, I have an example here. If x and y are random variable with sigma x squared equal to that, and you have the covariance. But let me quickly tell you this. X plus y, the variance of this guy is variance of x plus variance of y plus 2 covariance xy, variance of x minus y is variance of x plus variance of y minus 2 covariance xy, but situation where x and y, so if x and y are independent, if they are independent, then the covariance xy is going to be 0. You're only going to have just these two. Okay, now let's take a look at this question now. Okay, they want you to find the variance of this guy. Okay, you want to find the variance of that guy. Okay, the variance of 3s, okay, minus 4y plus 8. Now I need you to pay attention to what I want to do right now. Okay, this is the same thing as this. You know why? Because this is a constant, right? So I can also rewrite that as that. Now, if you take a look at this, this is similar to having as minus bs, where a and b are constants. Okay? Now, when you take a look at this, because they did not tell you whether they are independent or not, because in the question they say covariance is that, which means covariance exists. Now, what I'm going to do right now, please, I need you to pay attention. This is going to be variance of 3s plus variance of negative 4y, okay, plus 2 covariance, okay, 3s comma negative 4y. That is interpretation. Now, this is going to be 3 squared variance of x, negative 4 squared variance of y. Now, there's something, please, I need you to pay attention. When inside a covariance, a constant, I can bring out the constant 3, negative 4. What is 3 times negative 4? Negative 12, right? Times 2. That was why there's going to be negative 24, then covariance xy. Any question? And I can rewrite this as 9 sigma square x, 16 sigma square y, minus 24. Covariance of xy, another way to write it is sigma xy. What do you just need to do? You've been given all of that. You just start plugging them in. Okay, 2, 4, negative 2. So by the time you plug them in, you see what you got at the end of the day? Oh my God, you are done with that. Is that not super cool, right? That's how to do it. Now I'm going to move right now. How do we find covariance? You know, the other time, we find the expectation of a product. This is a covariance formula when the random x and y are discrete. Take a look at that. The covariance formula is the expected value of x minus mean of x, y minus mean of y. Now, the whole of this guy now is a random variable. So, if it is discrete, I'm going to have this and the f of xy. If it is continuous, oh my God, can somebody tell me something now? Covariance become what? If s equal to y. Can somebody tell me what covariance become for extra credit when s equal to y? If s is the same thing as y, can somebody tell me?
Yeah,
What does it become?
yeah, that's weird.
I know, there's a name.
Oh.
Instead of covariance, what do you call it when s equal to y? Instead of covariance.
There.
Variance. Send me a message for extra credit. You know, when I say variance, you know, if I'm looking at, if I have x and x, I'm looking at variation within. That is what we call variance. But if I'm talking about covariation, then I'm actually having more than x. I'm having x and y. Does that make sense? Okay, you know, the moment s is going to be equal to y, you're just going to have this guy here. You remember? It's just going to be squared. Okay, now, if it is continuous, this is how to get the covariance for continuous. Now, I want to move right now. Maybe, oh my God, I'm seeing a lot of finite questions here. Go ahead.
So for the covariance, did you take up 3 and negative 4 to get the negative 24, it looks like?
Yeah. Okay. That's a good question. We got a rule. If I have covariance AS, BS, okay, you know what's going to happen? But let me first walk you through this. You're going to see something now. Do you want to look up? You're going to see something now. If there's a constant here, what happened? This is going to be A squared variance of X. But for the where X and, oh, sorry, where X and Y are not the same, then it's going to be the constant will multiply. They're going to come out. Then I'm going to have this guy. Okay. Now, if that is taken now, oh, this time is so flying. Okay. Now, I got this guy now. And maybe I ask you to find the covariance. If you want to find the covariance, you're going to do a lot. You know what you're going to do? Because this is a formula. This is a final formula for covariance. Now, let me write the final formula for covariance. Okay, now take a look at this. Covariance. Let me use. Please look up and say this. Covariance of XY is expectation of a product minus this. Yeah. So covariance equal to this. And you know what? If the covariance equal to 0, this guy is going to be equal to that guy. So if I want to get the covariance, you know what I'm going to do? I need to first get expectation of a product. I need to get the expectation of S, which is what I'm doing here. Take a look at this. What do you think I'm doing? The first one, getting the expectation of X, getting the expectation of Y, okay? And I'm also going to get the expectation of a product. You know, I got the expectation of a product the other time, showing you this. Let me see if I work on the table. Do you see this? You know, we've gotten the expectation of a product. If I now want to get a covariance right now, because that question still continue. If I want to get a covariance right now, okay, what am I trying to tell the world? This is my covariance. You see that? If you want to interpret covariance, we only focus on the sign. Covariance only tells us the direction. It doesn't tell us the strength. But if I want to know the strength, you know, I'm talking about relationship. If I want to know the strength, whether strong or weak, I need correlation. You know what I'm going to do? Then I'm going to standardize covariance. Now, standardizing covariance will give us correlation. And this is, I'm going to write the formula now. Let me write the formula for correlation. Imagine I gave you a question and I asked you to find correlation. You're actually going to do a lot. If you want to find correlation is going to be raw. It's going to be covariance, xy, divided by square root of sigma s squared, sigma y squared. Which means you need to first get your covariance. And, you're also going to get this. Don't forget, this guy is this guy. That you also need to find this. Right? From the same data. And this guy. That you also need to find this. Can you see that? I'm going to continue from here on Monday.